Okay, so we are going to solve more equations. Last time we only solved equations where there was one variable on one side and usually there were numbers on the other. But this time we are going to solve equations where there can be variables on both sides. So key thing again is you want to remember to do opposites. So if it's positive on one side and you want to move it around, you have to do the opposite, which is subtract by the same term. So let's go through an example of how to do this. So example 1, we want to model equations with variables on both sides. So we have an equation here. We want to solve for x, and the equation is 6x plus 2 is equal to 10 plus 4x. And what we want to do is we want to get our variables all on one side of the equation. So this is how we do that. So I want to move this 4x over to the other side. So I want to get rid of it on one side. So to get rid of it on this right side, since it's positive 4x, I want to subtract 4x in order to get rid of it from one side and to move it to the other. And how we do that is you have to remember that whatever we do to one side, we also have to do to the other side. So I also subtract 4x from the other side. And what this does is gets rid of the 4x on the right side. So now I'm going to rewrite my equation. You have to remember how to add or subtract variables. So 6x minus 4x, well 6 minus 4 is 2. But this is the x family, so I need to include an x there, plus 2 equals 10. Awesome, so I have my variables all on one side, but the problem is I have this negative 2, or this positive 2 there. So I want to get rid of it from that side, and what I need to do is to move it over. I want to move it over to the other side. I'm going to subtract 2 from both sides, which cancels this out. So what I'm left with is 2x equals 10 minus 2, which is 8. And then I have one step left. This is 2 times x. I want x to be all by itself. So I need to divide both sides by 2. And that cancels out these 2's. So what I have left is x equals 4. So that's my answer for that. And we want to verify the solution. And how we do that is we found out that x equals 4, and all we need to do is substitute for the number 4 wherever there is an x. So what that means is you have 6x plus 2 equals 10 plus 4x. So wherever there's an x, I just replace that by the number 4 because x equals 4. So that's 6 times 4 plus 2 equals 10 plus 4 times 4. And if this is the right answer, both sides should be the exact same number. So this is 24 plus 2 is equal to 10 plus 16. And what we get is 26 equals 26, which is true. So that means x equals 4 is the right answer. All right, so for example 2, we're going to move to solving equations with rational coefficients. And all this means is your coefficients can be a fraction or sometimes not a fraction, but for these examples, fractions are fair game because so far we've only seen kind of whole number coefficients, but now we're going to see how to solve these when there are fractions. So let's take this first example. You have 22 divided by r. 22 divided by r equals 3. So we haven't seen it yet when the variable is on the bottom or the denominator. So what we want to do here is we want to multiply both sides by r. So I'm going to write this down. Multiply both sides by r. So that's what I did there. I multiply the left side of the equation by r and the right side of the equation by r. Now, I have an r on the top and r on the bottom, which means I can cancel out my r's there. So what I have left is 122 is equal to 3r. So I want to get the variable by itself. So on this right side, I have 3 times r. So the opposite of multiplying is dividing. So I need to divide both sides of the equation by 3. So these 3's cancel out. And what I'm left with is 120 over 3 is equal to r. Or you have 40.6 repeating is equal to r. So that's what I have for that first example. All right, so for example B, we have this equation that has fractions and variables. It can look a little scary, but let's just apply the same principles and the same steps that we've been doing, but now just with fractions. So we have 2a divided by 3 is equal to 4a divided by 5 plus 7. So keep in mind, we always want to get variables to one side. So I want to take this one right here. I want to take my 4a and I want to move it to the other side. So the way I do that is I am going to subtract 4a minus 5 from both sides of the equation because I want my variables to be all on one side. So this is going to cancel out. These cancel out. And what I'm left with is on the left side I have 2a over 3 minus 4a divided by 5 equals 7. So we got to remember from the first unit, these are fractions and we can't just add or subtract fractions. We need to create common denominators. So I'm going to multiply this by 5, top and bottom, times, and I'm going to multiply this by 3. So you got to remember how to multiply polynomials as well, right? If you have something like 2a times 5, you got to remember how to get that answer. So this is what we get. So 2a times 5 is 10a, and the denominator is 15. 4 times 3 is 12, but that's 12a over 15 equals 7. So that's what I have. Now you just got to subtract the numerator. So 10a minus 12a is negative 2a. Make my a little smaller. 2a over 15, which is equal to 7. Now I have a few more steps here. So I want the a to be by itself. So what I need to do, I have a 15 on the bottom, and that's dividing my 2a. So what I need to do is multiply both sides by 15. So that's going to cancel out. Now, what do I have? I have negative 2a equals 7 times 15. I'm not exactly sure what that equals, but let's check it out. 7 times 15 equals 105. All right. So now I have this last step here, 2 times a. I want to get rid of the negative 2. So I need to divide both sides by negative 2. Let me write this a little better. Negative 2. So this cancels out my 2. So I'm left with a is equal to, not sure what 105 divided by 2 is. Or negative 2, it's negative 52.5. So that's my answer. So key thing with these is always remember to move all your variables to one side. And we do that by adding or subtracting the opposite to move it over. And then just remember that you want to get the variable by itself. And that's the goal. So hopefully these help. Let me know if you have any questions.